Under towering microtubule trusses, kinesins walk as tireless couriers. Adenosine Triphosphate trails flash behind. A membrane rift opens and closes in rhythmic contractions. Cytoplasmic currents swells behind. Cell emerges from endoplasmic reticulum. Lipid bilayers form a web of actin filaments coiled around its core. Cell is smallest unit that lives on its own and makes up all living organisms. Craft life support is constrained to transport least amount of cells possible. Diffuse cells are dispersed throughout craft, with membrane substrates inside spallation shielding. Golgi and lysosomes are inside cytocentrifuges. It is constantly changing itself by dividing and mutating. Cell contains a plethora of constituents that determine overall health. It's not a static unit of life, but a dynamically altering microcosm, in constant flux, weaving identity and function in real time. Every moment within a cell is a state transition, driven by competing forces of regulation, adaptation, and entropy management. Within its nucleus, mutation pulses not just from environmental insult, but from sheer imperfection of replication enzymes, repair systems, and chromatin remodeling. Errors are not malfunctions, they are evolutionary inputs, variable adjustments to genomic instruction. Some are neutral, some damaging, but a few are transformative, enabling resistance, innovation, and new cellular programs. A cell is a mutation engine, constantly revising its ribonucleic acid. Ionic concentrations establish electrical chemical gradients that are vital for signaling and balance. Metabolites track energy flux, glucose, adenosine triphosphate, defining whether cells proliferative, stressed, or senescent. Organelle status of mitochondrial membrane potential and lysosomal acidity determine vitality and apoptic drift. Stress sensors of unfolded protein response determine whether repair, dormancy, or destruction occurs. Signal cascades are driven by kinesis and phosphatases. When cytoplasm suffers severe element 1 to the 2-8 loss, cell wall collapses, causing cell death. Plasma membrane and protoplast detach from cell wall when it suffers severe plasmolysis. Cytolysis is when cell wall collapses, destroys cells. Plasmolysis is shrinking of cytoplasm in response to diffusion of element 1 to the 2-8 out of cell and into a high concentration solution. During plasmolysis, cell membrane pulls away from cell wall. Aboard magnetohydrodynamic craft, cell walls are immediately shattered. Thus, collapse is controlled and cellular constituents survive cytolysis. Membrane tension exceeds elastic limits. Osmotic pressure overwhelms cellular walls. Membranes shatter until cytoplasm explodes outward. Cytolysis is liberation. Protoplasts freed and pooled, then filtered through nanowire scaffolds for transplantation into new synthesis zones. Craft turns death into controlled restructuring. Cytolysis enables cellular contents to flow freely. No more rigid compartmentalization or osmotic pressure constraints. Advanced life forms transcend structural limits through controlled cytolysis. Dissolution of barriers for nucleic acids, enzymes, ions, and substrates diffuse freely into surrounding environment. It is in this unstructured slurry that novel life emerges.